So, hello everyone, welcome. So, I think in the last class we discussed classical concept of oxidation and reduction, and we also discussed modern concept of oxidation and reduction. So, by these two concepts, we understood how can we define oxidation, how can we define reduction, and we also understood what is oxidizing agent and what is reducing agent. So then we also discussed how we can calculate oxidation state of an element in a molecule. So now in this class we will discuss types of redox reactions. Now we are familiar with the definition of redox reaction. Redox reactions are nothing but in any reaction both oxidation and reduction takes place. So now types of redox reactions. So there are four broad classifications of redox reactions: combination, decomposition, displacement and disproportionation reaction. So under displacement reaction we have two subclassifications: metal displacement and non-metal displacements. So we will study one by one now. First we will start with combination redox reactions. These are the redox reactions in which chemical compounds are formed by the combination of two or more elements. Combination of two or more elements. Okay, so first I will give an example, very simple example. Example 1, I can take combustion of carbon. Combustion of carbon. How can we write the reaction? Carbon undergoes combustion in the presence of oxygen. Combustion andre uriyodu. Carbon uriyodakke we have to supply oxygen, so this will give carbon dioxide. So here two reacting species are combining to form this product. So this is an example of combination reaction. But this is combination redox reaction. Redox reactions means undergoing one element will undergo oxidation and another one element will undergo reduction. See, in this case the oxidation state of the carbon is 0, because as per the oxidation state rules we defined that any element in its elementary form will possess 0 oxidation state. Oxygen same, 0 oxidation state in its elementary form. Okay, so oxygen is not combined with anyone, so in its elementary form oxygen also possess 0 oxidation state, like nitrogen 0 oxidation state, chlorine 0 oxidation state. So in their elemental form they will possess 0 oxidation state. So now come to this product side. So here as we know that one oxygen can exhibit 2 minus charge. Here two oxygen atoms are there, so 2 means 4 minus charge, so O2 will exhibit minus 4 charge. So in order to neutralize, carbon will exhibit plus 4 charge. So in this case carbon is undergoing increase in the oxidation state. So as we know that from the last concepts, increase in the oxidation state means carbon is undergoing oxidation, and here oxygen from 0 to minus 4. So here decrease in the oxidation state, so that is nothing but reduction. So in a single reaction oxidation and reduction both are occurring and elements are combining. So this is an example of combination redox reaction. Second example you can take, that is methane. Combustion of methane, that is CH4 plus oxygen giving carbon dioxide plus water. So balance this 2H2O 2. So this is a combustion of methane. This reaction is combustion of methane. Methane is undergoing combustion in the presence of oxygen. See, in this case what is the oxidation state of carbon here? As I know that one H will always most of the time possess plus 1 oxidation state. Here there are 4 H, so this will possess plus 4 oxidation state. So in order to neutralize, carbon will possess minus 4. Here carbon, as you know that oxygen, one oxygen will possess 2 minus, 2 oxygen will possess 4 minus. In order to neutralize that I have to put plus 4 on the carbon atom here. Then coming back to oxygen, as we know that oxygen in its elementary form will possess 0 oxidation state. In this case oxygen will possess 2 minus charge, or in this case oxygen will possess 4 minus charge. So anyhow, oxygen, the oxidation state of oxygen is decreasing. Okay, so here one oxygen atom shows 0 oxidation state, here two oxygen atom shows 4 minus, one oxygen atom shows 2 minus, but anyhow decreases, oxidation state decreases. So decrease in the oxidation state is nothing but reduction. So in this case, carbon oxidation state changes from -4 to +4, that is oxidation state is increasing, therefore this is oxidation. So in a single reaction, both oxidation and reduction are taking place. So this is redox reaction, and two reacting species are combining to give new product, combined product. That's why this is a combination redox reaction. Then move on to decomposition redox reaction. So here redox reactions we know already, in which chemical compounds undergo decomposition by itself or by heating. Decomposition is nothing but, in layman language, in common language, we can say breaking. Molecule is undergoing what? Breakage. It is going to break. That's all. Okay. With the example, we can understand easily. See, by itself or by heating. So a molecule will undergo decomposition by itself, ತಾನೇ ಡಿಕಂಪೋಸ್ ಆಗುತ್ತೆ. ಇಲ್ಲ ಅಂತಂದರೆ ಇಫ್ ಯು ಸಪ್ಲೈ ಸಮ್ ಟೆಂಪರೇಚರ್ ಆರ್ ಹೀಟ್, ಆವಾಗ ಬ್ರೇಕ್ ಆಗುತ್ತೆ ಮಾಲಿಕ್ಯೂಲ್ ಟು ಗಿವ್ ಪ್ರಾಡಕ್ಟ್ಸ್ ಕಂಟೈನಿಂಗ್ ಅಟ್ ಲೀಸ್ಟ್ ಒನ್ ಎಲಿಮೆಂಟಲ್ ಸ್ಟೇಟ್. ಸೊ ನಿಮಗೆ ವಿತ್ ಎಕ್ಸಾಂಪಲ್ ಐ ಕ್ಯಾನ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ದಿಸ್ ವೆರಿ ವೆಲ್. ಓಕೆ, ಸೊ simple example I will take. Water. Here's water. So when you heat the water, so water will undergo decomposition to form hydrogen and oxygen. Balance this 2 2. Okay, see, water is undergoing decomposition or breaking, undergoing break. Bond is going to break. So in order to form hydrogen and oxygen, so it is giving at least kadame andrunu ondadru elemental state anna kodutte anta. See here we have hydrogen in the form of elemental state or oxygen in the form of elemental state. So decompose ಆದಮೇಲೆ ಒಂದಾದ್ರೂ elemental state ಅಲ್ಲಿ ಇರುವಂತಹ molecule ಅನ್ನು ಕೊಡುತ್ತೆ ಅಂತಂತ. Or else take simple example, another one, potassium chlorate, that is KClO3, that is potassium chlorate. Potassium chlorate, when you heat this, you will get potassium chloride plus oxygen. Balance this, you will get like this. See here, this molecule, when we heat this, this will undergo decomposition or breakage, and it will give at least one elemental state. Elemental state ಅಂತಂದ್ರೆ free state of any element. Oxygen, see, nitrogen is a elemental state of nitrogen. N is also elemental state of nitrogen. If nitrogen combines with any other compound, this is not elemental state of nitrogen. If oxygen combines with any other molecule, then this is not an elementary form of any element. Okay, so molecule undergoes decomposition to give at least one elemental state. Okay, that is known as decomposition reaction. So in this case also you can work out how redox reaction is occurring. See, for example, here oxygen always exhibits, not always, most of the times commonly exhibits 2 minus. So in this case hydrogen will exhibit 2 plus. So 2 hydrogen will exhibit 2 plus. So 1 hydrogen will exhibit plus 1 state. So hydrogen possesses plus 1 state. So here hydrogen in its elementary form, as per the rules, oxidation state is 0. So plus 1 to 0. Hydrogen is changing its oxidation from plus 1 to 0, that is decrease in the oxidation state. So hydrogen is undergoing reduction. In this case oxygen 2 minus, in this case elementary form of any element will have possess 0 oxidation state. So minus 2 to 0, that is nothing but increase in the oxidation state. So oxygen is undergoing oxidation. So in same reaction we can see both oxidation and reduction. So this is an example of redox reaction, and along with that the molecule is undergoing decomposition or undergoing breakage to give at least one elemental state. So this is an example of decomposition reaction. The next is displacement redox reaction. Very simple. Redox reactions in which an atom or ion present in the chemical compound gets replaced by atom or ion of the another element. There is a replacement. Okay. Generally, I can represent with a simple mathematical equation like, consider this is an element X. Okay. When you treat this element with another molecule containing two elements Y, Z. So here what happens is this X will replace this Z or Y, anything. This will replace Z, and this X will go with Y. Okay, X Z ಅನ್ನು replace ಮಾಡಿ Y ಜೊತೆ ಹೋಗುತ್ತೆ. So you will get Y X, and Z will be replaced by X. So you will get Z separately. So there is a replacement of atom or ion, okay, of another element. So this is displacement reaction. There is a displacement or there is a replacement of position taking place. Z was with Y, now Z is going out of Y. X is replacing Z, isn't it? So with the chemical reaction we can understand easily. See, under this displacement reaction we have two subclassifications. One is metal displacement reaction and another one is non-metal displacement reaction. First we will learn what is metal displacement reaction. So here a metal in a compound can be displaced by another metal. So one metal will be replaced by another metal. So that is known as metal displacement reaction. So for example, take copper sulfate, that is CuSO4, copper sulfate. When you treat this with zinc, you will get copper plus zinc sulfate, ZnSO4. So here this zinc is replacing copper, isn't it? So copper is replaced by zinc. So this is an example of metal displacement reaction, because here zinc is also metal, copper is also metal. So metal is displacing another metal. So this is the simple definition of metal displacement. But why zinc displaces copper? Because this is an extra thing for you. See, zinc will replace copper because zinc is highly electropositive in nature. Highly electropositive in nature compared to copper. Okay. So copper is less electropositive than zinc. So a general thing is, any element which is highly electropositive in nature can replace an element which has lesser electropositivity than itself. Okay. So zinc will replace copper in this way. So how this is a redox reaction? How can we say this as a redox reaction? You can calculate oxidation number. Like, see, sulfate always possesses 2 minus oxidation state. So obviously in order to neutralize that, copper must possess 2 plus. So here zinc, so any element in its elementary form will possess 0 oxidation state. Here same 0 oxidation state. In this case, see, sulfate 2 minus, zinc 2 plus. So copper is undergoing change in oxidation state from 2 to 0. That is nothing but decreasing in the oxidation state. That is nothing but reduction as per the oxidation state concept, isn't it? So zinc 0 to plus 2. Oxidation state of the zinc is increasing, so zinc is undergoing oxidation. So in a single reaction, both oxidation and reduction are occurring. So this is an example of redox reaction. Along with that, metal is replacing another metal. So this is an example of metal displacement reaction. Then non-metal displacement reaction. So here these are nothing but hydrogen displacement reactions, where hydrogen is displaced. Hydrogen displace ಆಗುತ್ತೆ ಇಂಥ reactions ಗಳಲ್ಲಿ. Like there are some reactive metals like sodium, potassium, calcium, magnesium. Why these are reactive? Generally they are S block elements, and as you know that S block elements are of two categories, that is one is alkaline earth metals and alkali metals, isn't it? So both are highly reactive in nature, isn't it? And in lower classes you might have observed that sodium ಅನ್ನು ನೀವು ನೀರಿಗೆ ಹಾಕಿದ್ರೆ ಎಷ್ಟು ವಿಗರಸ್ ಆಗಿ ರಿಯಾಕ್ಷನ್ ಆಗುತ್ತೆ ಅಂತಂತ. And do you know this thing that potassium, sodium are all explosives, okay? So ಅದನ್ನ ಬಾಂಬ್ ಮ್ಯಾನುಫ್ಯಾಕ್ಚರಿಂಗ್ ಅಲ್ಲೆಲ್ಲ ಯೂಸ್ ಮಾಡ್ತಾರೆ. So these highly reactive elements will replace hydrogen when we treat it with water, okay? So with the reaction we can understand this. See, non-metal displacement reactions, for example, when you treat highly reactive elements like sodium with water, so this sodium, since it is highly reactive, this sodium will replace hydrogen to form NaOH plus hydrogen. When we balance this, we will get 2, 2, 2 here. So here this sodium is replacing one hydrogen atom to form NaOH and hydrogen gas. So this is an example of non-metal displacement. How is the redox reaction? Calculate the oxidation state of each element. Sodium in its elementary form exhibits 0 oxidation state. So here oxygen most of the cases exhibits 2 minus. So in order to neutralize, hydrogen will exhibits 2 plus. So here 2 hydrogen exhibits 2 plus, but 1 hydrogen will exhibit plus, isn't it? So oxidation state of the hydrogen, single hydrogen, is plus 1. Then sodium, as you know that OH always exhibits OH minus. So here exists as OH minus. So sodium will exhibit plus. Hydrogen in its elementary form 0 oxidation state. So in this case sodium oxidation state is changing from 0 to plus 1, that is nothing but increasing. So sodium is undergoing oxidation. So in this case hydrogen is decreasing its oxidation state from plus 1 to 0, nothing but decrease in the oxidation state is nothing but reduction. So this is in single reaction both oxidation and reduction can be observed, and there is a displacement of hydrogen by the highly reactive elements. So this is an example of non-metal displacement reaction. So you can take plenty of examples, okay? Take another example like magnesium. Magnesium reacts with water to give magnesium hydroxide plus hydrogen. So in this reaction balance this 2. So very simple. See here magnesium is replacing hydrogen to form magnesium hydroxide, right? So how you can calculate oxidation state here? Magnesium in its elementary form shows 0 oxidation state. So here oxygen shows 2 minus state and hydrogen shows 2 plus state, but single hydrogen will show plus 1 state, isn't it? Or 1 plus or plus 1. Here OH, one OH will exist as OH minus, 2 are there, so 2 minus. So here in order to neutralize that Mg 2 plus. So here hydrogen in its elementary form shows 0 oxidation state. So magnesium oxidation state changing from 0 to plus 2, that is nothing but increasing. So magnesium is undergoing oxidation. So here oxidation state of hydrogen decreases from plus 1 to 0, isn't it? Plus 1 to 0. So decreasing is nothing but reduction. And I think you know, see, if 2 hydrogen exhibits 2 plus state, then 1 hydrogen will exhibit plus 1 state. That's what I have written here, okay? So this is how we can conclude this non-metal displacement reaction. I hope you understood this. The next is disproportionation reaction. Very simple. Last, disproportionation reaction is nothing but redox reactions in which a species is simultaneously reduced and oxidized to form two different products, okay? So single reactant will undergo reduction as well as oxidation. See, with the example we can understand. I think you heard about this compound. What is this? Hydrogen peroxide. Hydrogen peroxide This will undergo reaction as follows. This will give water plus oxygen. So you can see here, see hydrogen peroxide undergoes reaction to form water and oxygen. So how can you calculate oxidation state here? See, as you know that hydrogen exhibits plus 1 oxidation state, isn't it? Plus 1 oxidation state. But here there are two hydrogen atoms, so overall molecule will exhibit plus 2 oxidation state. So in order to neutralize plus 2, O2 must possess minus 2 oxidation state. So since two oxygen atoms possess minus 2, then one oxygen atom will possess minus 1 oxidation state. So single hydrogen possesses plus 1, single oxygen possesses minus 1 in this case. Okay. So here water, as you know that water will possess, oxygen will possess 2 minus oxidation state, hydrogen will possess plus 2 oxidation state, 2 hydrogen plus 2, 1 hydrogen plus 1, that's all. So here oxygen in its elementary form always shows 0 oxidation state. So here in this case you can observe oxygen molecule. So in this case single oxygen was showing minus 1 oxidation state. Here single oxygen is showing minus 2 oxidation state, that is minus 1 to minus 2 means decrease in the oxidation state. So that is nothing but reduction. So but the same oxygen here shows 0 oxidation state, that is minus 1 to 0 oxidation state, nothing but increase in the oxidation state. So it is nothing but oxidation. So same oxygen atom undergoes both reduction as well as oxidation. So simultaneously reduction as well as oxidation to form two different products. Two different products. So such reactions are nothing but disproportionation reaction. You can take another simple example like chlorine Cl2, chlorine molecule reacts with OH minus ions. OH minus ions are nothing but hydroxide ions. Hydroxide ions. Okay. And that will give ClO minus. ClO minus is nothing but chlorate. Chlorate ion plus chloride. Cl minus is chloride, and along with that we will get water. So when we balance this we will get 2 OH minus here. So now see in this reaction calculate the oxidation state of individual elements. So chlorine in its elementary form 0 oxidation state. Here chlorine, since oxygen is possessing minus 1 oxidation state here, chlorine must possess plus 1 oxidation state, right? The next is, see how I calculated this. You need certain introduction for this, some introduction for this. ClO minus, chlorine O minus. See in this case, wait for a minute. Okay, in this case how can we calculate oxidation state of this ion? See, as we know that oxygen will possess minus 2 oxidation state, and I need to calculate oxidation state of chlorine. Let us take oxidation state of chlorine as X, plus oxygen will possess oxidation state of minus 2. We know oxygen will exist as minus 2. So X plus minus 2 is equal to what is the overall charge on the molecule, that is minus 1. So X plus into minus, minus 2 is equal to minus 1. Therefore X will be equal to minus 1 plus 2. When you shift this to RHS side, you will get plus 1. Therefore chlorine will attain plus 4 oxidation state. I think you are getting this. Okay. See, if you can't understand this, please come and ask me. So in this case, here chlorine molecule exhibiting -1 oxidation state. They have already written this. Okay. So here chlorine molecule is changing its oxidation state from 0 to +1. That is increase in the oxidation state. That is nothing but oxidation. So same chlorine molecule changing its oxidation state from 0 to -1. That is nothing but decrease in the oxidation state. That is chlorine is undergoing reduction. So in the same reaction, chlorine molecule undergoing simultaneously undergoing reduction as well as oxidation to form two different products. So this is an example of disproportionation reaction. So this is all about this types of redox reactions. I think you can easily understand this. Once again, if you can't able to understand, watch the video once again, and then also if you are not able to get that, please come to me and you can ask. Okay, so we will wind up the class now, and by the next class we will start with the concept of what, balancing a chemical reaction. Okay, so we will start with this balancing a chemical reaction. So where we will get two different methods to balance a reaction. It is oxidation method and ion electron method. So somewhat tricky, but you can easily learn this. Okay, not a complex subject, not a complex topic. So I will make you to understand in a easy manner. So till that you revise all old concepts. Okay.